Hello and welcome. In our previous video, we created a serverless note-taking service on AWS using serverless framework and AWS Lambda. But let's be honest, our functions were pretty boring. They just return a string. In order to make our functions useful, we need to set up a database and add some logic. To do this, we're going to set up the DynamoDB database. Okay, enough talking. Let's get started. Let's start by opening our serverless YAML file. We will create a new resources section to define our new DynamoDB table. We will name it node table and specify its type as AWS DynamoDB table. Then we will define its properties, including its table name, key schema, attribute definitions, and provisioned throughput. The key schema determines how our data will be organized in the table. We will use a composite primary key made up of two attributes, user email and node date. User email is the partition key, also known as the hash key, and helps distribute our data across multiple nodes in the DynamoDB cluster. Node date is the sort key or range key and is used to sort the data within each partition. Our attribute definitions will define the data types and the names of the attributes in our table. We will create two attributes, user email and node date, one of the string type and another one of number type. We don't have to specify other attributes. They will be added dynamically. Only the primary key of the table has to be defined up front. Lastly, we will specify the amount of read and write capacity units our table will have. In our case, we'll go with 5 read operations and 5 write operations per second. Now that we have defined the DynamoDB table, we need to add proper IAM role to the Lambda functions so that they can access the database. We can achieve that by using the IAM role statement section in our serverless YAML file. There are two ways to define the IAM role statements. We can either add them to the providers section, which applies the role to all of our functions. Defining the IAM role statement in YAML syntax is similar to defining it in JSON. Firstly, we set the effect clause to allow for necessary actions. Since we have 3 Lambda functions, one for getting all nodes, one for creating a node, and one for deleting a node, we need to allow access to the DynamoDB query, DynamoDB put item, and DynamoDB delete item APIs for our Lambda. Finally, we need to specify the resource to which this role is applied to. I recommend using the fn get att function from AWS CloudFormation to get the ARN automatically. To use this function properly, we need to specify the resource name as the first argument and the attribute we want to get as a second argument. This function returns a specific attribute from a resource, making it easy to get the ARN dynamically. Excellent! We have completed all of the necessary steps in our serverless YAML file. But before we move forward, let's make sure that everything is error-free and good to go. To validate our configuration, we can simply use the SLS package method. This will check out our config and build and save all of the dependencies artifacts. It's a simple and hassle-free way to ensure that our config is correct. Once we've run that command, we'll see that service is packaged, meaning there were no problems in the YAML file. Great, we're halfway through. Take a deep breath to refocus. And when you're ready, let's continue with implementing the handler functions. Let's open the handler.js file. To get started with our Lambda function, we will import the AWS SDK. Fortunately, we don't need to install the SDK as it's already available in the AWS infrastructure by default. Next, we will initialize the DocumentClient from the DynamoDB, which is an abstraction that simplifies working with DynamoDB. Moving on to the addNode function, we will begin by extracting the node from the event body. Currently, we don't have an authorization system in place, so we will hardcode the user's email for now. However, we will refactor this in the future to extract the email from the token attached to the request. Now, we will create a new item in DynamoDB. In the DynamoDB world, an item is the name of the object that's saved in the database. To confirm to the key we have specified in the YAML, we will save email and the node date in the item. Also, we will save the node text. After creating the item, we will prepare the params object for the put method. The put method expects us to specify the name of the table where we will put the item, as well as the item itself. With our setup in place, we can now use the put method of the document client, passing the params object to it. We can then use the promise method on it and await for the result. It's also a good practice to wrap this call with a try and catch clause. If the request succeeds, we will return a 201 status code and a string message. If the request fails, we will return 500 status code and attach the error to the message. And that's it. With these steps, we can create a node and save it to our database. To delete a node, we must first correctly identify it. In a previous lesson, we set up the endpoint having the node ID in the path. However, there is no ID property. Instead, we defined a composite key in DynamoDB using the user's email and node's date. While we will read the email from the token in the future, for now we will use the hard-coded version. So, to delete a node, we need to know its date. Let's change the node ID to node date in the YAML file first. And let's go back to the handlers file. To delete the item in the DynamoDB, we need to specify its key and the table name. Let's save it in the params object. With this configuration, we're ready to use the delete method of the document client. In fact, we can copy and paste the code from the addNode method and only change the method name and returned messages. Finally, we will implement the API to fetch all nodes belonging to a specific user. To do so, we need to prepare the params we will send. Firstly, we need to set the table name. Then, we need to set the key condition expression and expression attribute values. The key condition expression defines how we will search, while the expression attribute values map placeholders to accurate values. In our case, we're simply searching by user email. With the params ready, we can again copy and paste the code from the above method, changing the method to the query and returning the nodes we've just received from the database. And that's it. Our API is implemented. Now we can deploy it. Let's simply type SLS deploy and wait for the result. Great. Now we can see all endpoints URLs printed in the console. Let's firstly check if we can create a node. For that, I will simply type the test node text and hit send button. Cool, 201 status. Now, let's check if we can fetch all nodes. Yes, this endpoint also works. Finally, let's copy the delete endpoint and then let's add the timestamp at the end of the path and let's click send. Cool, once again, it works. Great job! In today's video, we have learned how to add DynamoDB database to serverless stack and how to save some data in it. However, our app is still missing some major features. In the next video, I will show you how to easily validate methods input to ensure data correctness. Meanwhile, thank you for the watching and see you next time.